Before Let's Encrypt, SSL certificates cost money. A basic DV certificate ran anywhere from 0 to 00 per year per domain. More complex OV and EV certificates cost hundreds to thousands of dollars annually. For small projects, independent developers, and nonprofits, HTTPS was a significant expense. The certificate issuance process was also manual. You had to generate a certificate signing request, send it to the CA, wait for verification, download the certificate, install it, and repeat annually. Many developers simply didn't bother with HTTPS for small projects. Let's Encrypt changed this completely. Launched in 2016 by the Internet Security Research Group, it offers free domain-validated certificates with a 90-day validity, using the ACME protocol for fully automated issuance and renewal. The impact was immediate and massive. HTTPS adoption went from about 40% of web requests to over 95% in a few years. Certification became a non-event, something you set up once and forget about. The philosophy behind Let's Encrypt, HTTPS should be the default for everything on the web. The cost and complexity of certificates was an artificial barrier. Removing that barrier was more beneficial to internet security than any other single intervention. For you as a developer, Let's Encrypt means HTTPS is free and takes about 5 minutes to set up on any server. There is no reason not to use HTTPS on anything you deploy. The Certbot tool handles everything: issuance, installation, and renewal. Certbot is the official Let's Encrypt client, maintained by the Electronic Frontier Foundation. It implements the ACME protocol and handles all interactions with Let's Encrypt servers. Installation on Ubuntu/Debian, sudo apt install certbot Python 3 certbot Nginx. This installs certbot and the Nginx plugin, which allows certbot to automatically modify your Nginx configuration. Installation via snap, the recommended method on newer Ubuntu. Sudo snap install classic certbot. Then create a symbolic link, sudo lns/snap/bin/certbot/usr/bin/certbot. The snap version is kept up to date automatically. After installation, verify, Certbot version should show the installed version. Prerequisites for Certbot to work: your domain must be publicly accessible, DNS must resolve to your server's IP, and the IP must be reachable from the internet on port 80. Certbot's HTTP 01 challenge makes an HTTP request to your domain to verify ownership. Nginx must be installed and running. The Certbot Nginx plugin reads your Nginx configuration to understand which domains are configured and modifies the config to add SSL. Firewall/cloud security group, port 80 and 443 must be open. Port 80 is needed for the HTTP 01 ACME challenge, even if you're going to force HTTPS afterward. Port 443 is needed for HTTPS traffic after the certificate is issued. Let's Encrypt rate limits. You can issue at most 5 duplicate certificates per week for the same domain. The staging environment has higher limits and is useful for testing. Add staging to Certbot commands to use the staging environment. Certbot's Nginx plugin is the easiest path to HTTPS if you're already using Nginx. It reads your existing Nginx configuration, requests the certificate, and automatically updates your Nginx config with the SSL directives. Step 1. Ensure Nginx has a server block for your domain. You need server_name emyap.com in your Nginx configuration before running Certbot. The plugin uses this to know which domain to get a certificate for. Step 2. Run Certbot, sudo certbot nginx d emyap.com d www.emyap.com. The D flag specifies domains. Include all domains you want on this certificate. You can have up to 100 domains on one Let's Encrypt certificate. Step 3. Certbot prompts, enter your email address for renewal reminders and security notices. Agree to the terms of service. Optionally, subscribe to EFF's email list. Step 4. Certbot performs the ACME challenge. It temporarily configures Nginx to serve the challenge file at /.wellknown/acme/challenge/. Let's Encrypt servers verify it. Certificate is issued. Step 5. Certbot updates Nginx configuration. It adds SSL_certificate, SSL_certificate_key, and SSL security settings to your Nginx config. It also offers to redirect HTTP to HTTPS. Choose yes. Step 6. Certificate is stored at /etc/let'sencrypt/live/myapp.com/. Nginx is reloaded to apply the new configuration. Verify success. Curly https://emyap.com should return http://2200 with no certificate errors. Also check the certificate details. Certbot certificates lists all installed certificates, their expiry dates, and the domains they cover. When Certbot runs with the Nginx plugin, it modifies your Nginx configuration. Understanding what it adds helps you maintain the configuration afterward. In your server block, Certbot adds SSL_certificate /etc/let's encrypt /live/myapp.com /fullchain.pem, the certificate path. SSL_certificate_key /etc/let's encrypt /live/myapp.com /privkey.pem, the private key path. Includes /etc/let's encrypt options SSL_Nginx.conf, includes let's encrypt's recommended TLS settings. SSL_param /etc/let's encrypt /SSL_params.pem, Diffie-Hellman parameters for forward secrecy. The options SSL_Nginx.conf file contains security-hardened TLS settings from Let's Encrypt. It specifies which TLS versions to support, 1.2 and 1.3, which cipher suites to allow, and security headers. The HTTP redirect, Certbot creates or modifies the server block on port 80 to add a return 301 redirect to HTTPS. After Certbot modifies your config, always run sudo nginx to verify the configuration is valid, then sudo system_reload nginx to apply changes. Manual versus Certbot managed config. If you prefer to manage your Nginx config manually, use Certbot certainly Nginx or Certbot certainly webroot instead of Certbot Nginx. This gets the certificate without modifying your Nginx config. You then add the SSL_certificate directives manually. The advantage of manual, you have full control over your Nginx configuration. The advantage of Certbot Nginx, it handles everything automatically, including the redirect. For learning purposes, reviewing what Certbot adds to the config and understanding each directive is valuable. Certificate renewal is more important than initial issuance. A site that gets an HTTPS certificate but whose certificate expires is worse than having never had HTTPS. It actively fails for all users. How Certbot sets up automatic renewal. On Ubuntu/Debian, Certbot installation creates a systemd timer called snap.certbot.renew.timer, or certbot.timer. You can verify it with system.status snap.certbot.renew.timer. The timer runs Certbot renew twice daily at random times. Certbot renew checks all installed certificates and renews any that will expire within 30 days. If no certificates need renewal, it exits without making any changes. After renewal, Nginx must be reloaded to use the new certificates. Certbot handles this via deploy hooks. A deploy hook runs after each successful renewal. Certbot's Nginx plugin installs a deploy hook that runs system.reload Nginx. Verify the renewal process works, sudo certbot renew dry run. This simulates the renewal process without actually making changes. If it outputs, congratulations, all renewals succeeded, or no renewals were attempted, renewal is working. Run this after initial setup to confirm. What can break automated renewal? Nginx not running when renewal runs. Certbot can't complete the HTTP 01 challenge. Ensure Nginx is always running and configured to autostart. Port 80 blocked. The ACME challenge requires port 80. Don't close port 80 thinking we only use HTTPS. Keep port 80 open in the firewall, but redirect all traffic to HTTPS. Rate limit hit. If something tries to renew too many times, Let's Encrypt's rate limit blocks further attempts for a week. Don't run Certbot renew manually in a loop. Monitor certificate expiry. Use an external monitoring service to alert when certificates have less than 14 days remaining. The HTTP 01 challenge requires port 80 to be accessible from the internet. The DNS 01 challenge doesn't. It proves domain ownership through DNS, not through HTTP. When to use DNS 01, getting wildcard certificates, star.myapp.com. When your server is behind a firewall and port 80 isn't publicly accessible, internal tools, when you have multiple servers behind a load balancer without shared storage for challenge files. How DNS 01 works. Certbot generates a random value, adds it as a TXT record at _acme-challenge.myapp.com, Let's Encrypt queries DNS to verify it, then issues the certificate. The TXT record is then removed. Manual DNS 01, not automated sudo certbot certainly manual preferred challenges DNSD-myapp.com dstar.myapp.com. This pauses and tells you exactly which TXT record to add. You add it manually, press enter, and Certbot completes the validation. The problem, manual DNS 01 doesn't automate renewal. You'd need to do this every 90 days. Automated DNS 01 with Cloudflare. Certbot DNS Cloudflare plugin automates the TXT record creation and deletion. Install, sudo pip install Certbot DNS Cloudflare. Create a Cloudflare API token with DNS edit permissions. Create a credentials file /root/.secret/cloudflare.ini with DNS_Cloudflare_API_token equals your _token. Run, sudo certbot certainly DNS Cloudflare credentials /root/.secret/cloudflare.ini dmyapp.com dstar.myapp.com. Renewal is then fully automated. Certbot creates and removes TXT records automatically. Other DNS providers, Certbot has plugins for AWS Route 53, Google Cloud DNS, DigitalOcean, and many others. All work similarly to the Cloudflare plugin. Let's Encrypt enforces rate limits to prevent abuse. Understanding them helps you avoid hitting them accidentally. Key rate limits for production: certificates per registered domain, 50 per week. You can issue 50 certificates for myapp.com and all subdomains per week. This includes renewals. Normal usage won't hit this limit. Duplicate certificate limit: 5 identical certificates, same domain set, per week. If you run Certbot Nginx myapp.com 5 times in a week, the 6th attempt is blocked. This limit catches runaway automated systems. Failed validation attempts: 5 per hour per domain per account. If the ACME challenge fails 5 times in an hour, you're blocked from further attempts for that domain for an hour. Accounts per IP: 10 per IP per 3 hours. Rare to hit unless running Certbot from a shared IP. The staging environment: Let's Encrypt has a staging environment with much higher rate limits for testing. Certificates from staging aren't trusted by browsers, they're signed by a fake CA, but otherwise work identically. Use staging when testing your Certbot setup, add staging to Certbot commands. Checking your rate limit status: there's no direct API. If you hit a rate limit, the error message specifies which limit and when it resets. Common fix: use staging for testing, switch to production only when you're confident the setup works. Practical advice: don't run Certbot interactively to test, use try run. Run the actual certificate issuance only when your setup is confirmed working. This preserves your rate limit budget. As your projects grow, you'll manage certificates for multiple domains and multiple servers. Here's how to maintain them efficiently. Listing all installed certificates: Certbot certificates. Shows each certificate's domain list, expiry date, and file paths. Adding a domain to an existing certificate: if you add a new subdomain, api.myapp.com, and want to include it in an existing certificate, rerun Certbot with all domains, sudo certbot nginx myapp.com www.myapp.com dapi.myapp.com. This expands the certificate. Deleting a certificate: Certbot deletes certname myapp.com. This removes the certificate files and Nginx configuration entries. Use when you're removing a domain entirely. Separate certificates for different projects: if you run multiple projects on the same server with different domains, each gets its own certificate. Certbot manages all of them independently. All renew automatically. Certificate files location /etc/let's encrypt /live/ contains directories for each certificate. /etc/let's encrypt /renewal/ contains renewal configuration files, 1 per certificate. Don't modify the renewal config files manually. Migrating certificates to a new server: copy the /etc/let's encrypt directory to the new server. Install Certbot on the new server. The certificates and renewal configs transfer with the directory. Run Certbot renew to verify the certificates are valid on the new server. Multiple servers for the same domain: load balancer setup: all servers need the same certificate. Options: use a shared storage for Let's Encrypt files, use Nginx as a load balancer on a single front-end server, or use Cloudflare's SSL which terminates at the CDN edge, no certificate needed on back-end servers. Certbot failures are usually straightforward once you know the common causes. Error: problem binding to port 80 or unable to bind to port 443 cause another service is already using that port, or Nginx isn't running. Fix: sudo system status Nginx. If Nginx is down, start it. If something else is on port 80, sudo sstlnp grep 80 identifies the process. Error: DNS problem, next domain looking up a for myapp.com cause DNS isn't resulting to your server yet. Either the record doesn't exist or hasn't propagated. Fix: verify dig myapp.com returns your server's IP. Wait for DNS propagation if you just created the record. Error: connection refused or timeout during ACME challenge cause port 80 is blocked by the firewall, cloud security group or firewalled. Fix: ensure port 80 is open. Sudo firewall cmd listall should include HTTP in services. Error: certificate not yet due for renewal when trying to force renew cause the certificate has more than 30 days left. Certbot renew skips it. Fix: sudo certbot renew force renewal overrides this check. Or use dry run just to test. Error: failed to renew certificate, webroot path not found cause Nginx configuration changed and the webroot path Certbot is using no longer exists. Fix: Certbot needs its challenge file served at /.wellknown/acme challenge/. Ensure this path is accessible in your Nginx config. If using the Nginx plugin, not webroot, rerun Certbot Nginx. Certificate file permissions error, cause etc let's encrypt live or etc let's encrypt archive has wrong permissions. Fix, these should be owned by root. Sudo chown or root etc let's encrypt . A scenario about the renewal process. You set up Let's Encrypt on your server 85 days ago. You notice the certificate expires in 5 days. You log in and see Certbot's systemd timer is not running. You run sudo certbot renew and get an error, problem binding to port 80, listen TCP 0.0.0.0:80, bind, address already in use. What happened and how do you fix it? Option A, the certificate expired and you need to issue a new one. The certificate hasn't expired yet, it expires in 5 days. Certbot renew should be able to renew it. But there's another problem blocking the renewal. Option B, Nginx stopped running so Certbot can't serve the ACME challenge. Partially correct direction, but the error address already in use means something is using port 80, but it might not be Nginx. If Nginx weren't running, port 80 would be available. Option C, Certbot is trying to bind to port 80 for its own standalone server, but Nginx is already using port 80. Without the Nginx plugin flag, Certbot standalone mode tries to create its own HTTP server on port 80. Since Nginx is on port 80, it fails. Run sudo certbot renew Nginx or ensure the renewal config file uses the correct authenticator. This is the correct diagnosis. Option D, you need to stop Nginx, run certbot, then restart Nginx. This is what standalone mode requires. But with the Nginx authenticator, you don't need to stop Nginx, Certbot uses Nginx to serve the challenge. Check etc let's encrypt renewal myapp.com.conf for the authenticator setting. If it says authenticator equals standalone, change it to authenticator equals Nginx. The answer is C. The renewal configuration is using standalone mode. The fix, update the renewal config to use the Nginx authenticator, or run certbot Nginx to reinstall the certificate with the Nginx authenticator.